Atul, Ayush,
Yes, sir.
Balmukund,
Present, sir.
Bharti,
Present, sir.
Chaitanya,
Present, sir.
Danyashree,
Present, sir.
Gule Ritesh, Gulabi,
Present, sir.
Kalpesh, Kaushal,
Present, sir.
Present, sir.
Kunal,
Present.
Manoj,
Present, sir. Present, sir.
Mayur, Ojas,
Present, sir.
Omkar,
Present, sir.
Present,
Omkar
sir.
PC, Omkar PC,
Present,
Omkar,
sir.
Omkar,
Present, sir.
Samiksha,
Present, sir.
Prathamesh,
Present, sir.
Raghav,
Present, sir.
Raj,
Present, sir.
Ramya,
Present, sir.
Riya, Rohit,
Present,
Samruddhi,
Present, sir.
Sapna,
Present, sir.
Shashiranjan,
Present, sir.
Shashidhar, Srihar,
Present, sir.
Sneha,
Present, sir.
Sonali, Sumit,
Present,
Present, sir.
Sumit, SD, Sumit,
Present, sir.
Swastika, Swastika, Tejaswini S,
Present, sir.
Triambak, Umesh, Umesh,
Present, sir.
Vaishnavi Jadhav,
Present, sir.
Vaishnavi N,
Present, sir.
Vedant, Vishal,
Present, sir.
Present, sir.
Yash. Okay. Start today class in the chemical bonding. Yesterday we completed that Lewis structures, right? Lewis structures. Now in that Lewis structure we have taken what valency electrons, right? Now let me see what happened. Some more negative charge species. For negative charge species, how to make the Lewis structures here. So you have textbook with you, all of you?
Yes, sir.
Textbook, right? Now in that you see this Lewis symbols now. Problem number 4.1 we have done yesterday. Yes, that CO molecule we completed. Correct. Next we'll see what happens. Some exercise we'll do now. Some of the exercise we'll do now here. How to make the Lewis structure for this exercise. Now if you observe what happened here, फॉर्मेशन ऑफ केमिकल बॉन्ड आप ये कर सकते हैं ना, इसमें कुछ प्रॉब्लम नहीं है आपको. राइट द लुईस डॉट सिंबल्स, मैग्नीशियम सोडियम ये सारी आप कर सकते हैं. 4.1 यू कैन डू, 4.2 यू कैन डू. नाउ लुईस सिंबल फॉर द फॉलोइंग एटम्स, देखो बेटा S-2 एंड एल्यूमिनियम +3, ये आपको कैसे करना है. तो यू हैव टू सी समथिंग लाइक दिस. फर्स्ट ऑफ ऑल विल टेक सल्फर configuration. If you observe here what happened, valency shell I'm writing, only valency shell, 3s2, only I'm writing valency shell better, 3s2. You have to compulsory up to atomic number 30. Everyone should know its atomic number and electronic configurations. Understood? Up to 30 element, you should know that all electronic configurations here. Now 3s2, 3p4 is a valency electrons. So we have to write how many? 6 electrons, right? 3s2, 3p4, we can write 6 electrons. But 2 minus indicates it has extra 2 electrons. So I have to add 2 more electrons to this one. I have to add 2 more electrons to this one. So now in this case, what happened? Actually 6 electrons are there plus 2 electrons. You have to make like this structure, 8 electrons. This will be the structure of what? S minus 2, and also looks like what? Argon structure, just like argon Lewis symbol actually. Is it visible for you? Whatever I'm writing on the PDF, is it visible for you?
Yes, sir.
Right. So you got how to write S minus 2. Now how to write aluminum plus 3 beta? How to write aluminum plus 3?
3 dots, sir.
In that case, we have to remove 3 electrons. Remove 3 electrons. I will show this one. Aluminium actual configuration is what? I'm writing again valence electron 3s2, 3p1. So you have to write 3 electrons in the Lewis symbol. But aluminum plus 3, no. Now remove these electrons here. Remove these electrons. Now it will be what? 2s2, 2p6, 3s2, 3p1. Okay. Now I have removed this one. No. Which electrons I have removed? This one I have removed here. Now this electrons we have to write. So again, how many? 8 electrons. Aluminum compulsory. Otherwise, what happens? Aluminum does not have any electron here. So if you remove these 3 electrons, aluminum does not have any electron here. Outermost electrons are 0 here. Understood here? Outer electrons are don't have any electrons here. Correct? Right. Next, draw the Lewis structure for the following molecules and ions. मैंने आपको बोला CO3-2 डिस्कस करूंगा आज, और एक इसमें एक मॉलिक्यूल भी डिस्कस करूंगा मैं, 2 इसमें एक और इसमें भी डिस्कस करूंगा. CO3-2 कैसे लिखना है यहाँ पर? So first of all, you have to take what? Carbon and oxygen. Now oxygen configuration is what? 2s2, 2p4. This one will be 2s2, 2p2. The letters is visible for you. Is it smaller? What shall I write? Bigger one. Whatever I'm writing the letters.
They are visible.
Visible, no? Now here how many electrons I have to write? 4 valency electrons I have to write. Here how many electrons I have to write? 6 valency electrons I have to write. And extra, it has 2 minus, means what? Extra 2 electrons plus add 2 electrons. So first of all, I'm writing here carbon, oxygen, right? Now here I have to show 4 electrons here. I'm showing electrons like this: 1, 2, 3, 4. For oxygen, I'm showing in the form dot like this. How many I have to show? 6 electrons I have to show. 1, 2, 3, 4, 5, 6 electrons. Now what happens here? You have here 3 oxygens are there. How many are there? 3 oxygens are there. Now put here 3 oxygens. Shall I take on PowerPoint? That it will be easy for you. I will take on PowerPoint. देखो बेटे यहाँ पर एक so carbon, oxygen. Now I am putting what? Carbon here, oxygen here, and oxygen here. So CO3 minus 2, right? 1 carbon, 3 oxygens. Now put here how many electrons I have to put here for carbon? 4 electrons, correct? So I'm putting here 1, here 2, here 3. Right? One more electron I'm putting here. So total what happened? 4 electrons are complete. Next, for oxygen, 6 electrons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Again here what happened? 1, 2, 3, 4, 5, 6. Now every valence electrons are completed. All the electrons of this element valence electrons are written. For carbon 4, for each oxygen 6 electrons. Right? Now extra 2 electrons you have. These electrons you have to put here. Now what I am doing here, between these two one bond is possible. Correct? Between these two also one bond is possible here. Similarly, between these two, I am writing this electron here. So shall we write like this here? This electron and this electron I am writing here. Now between these two a bond is possible. Between these two a bond is possible. Now all the 4 electrons of carbon is completed. Correct? Now what I am doing here, these 2 electrons, this -2, extra 2 electrons, if I take something like this, one here, other is here. Okay, one more bond I am getting like this. Okay, one more I am getting here. Now let me see how many electrons having around the oxygen here. Okay, now here 2 electrons, I am writing something like this. This oxygen having how many electrons? Tell me. 2, 4,
8.
8 electrons. Octet is completed. Now let me see this oxygen is having how many electrons?
Sir, 8.
8 electrons. So it is also completed. Let me see this oxygen also. I'm seeing this oxygen. It is also having 8 electrons. What about the must think central atom we should have? See first of all. But once we complete oxygen, let me see now central atom. Carbon have how many electrons? You see.
So 6.
4. Isn't
6,
it? Sorry. Just a minute. Now you have 2 electrons like this. Now how many electrons it is having? 2, 4, 6, 10 electrons it is having. Now because of what actually? These 2 extra electrons actually. Isn't it? This carbon has actually how many? 2, 4, 6, 8, 10 electrons it is having. It has something 10 electrons. But outermost shell they are having what happened? 8 electrons. Now extra, why it got 10 electrons? Because extra CO3 minus 2, the 2 extra electrons, isn't it? They also participated in the bonding. So that what happened? You got this structure. Actually CO3 minus 2 looks like this. C double bond O, isn't it? CO minus, CO minus. So that is the reason what we'll do actually. Will make the 2 this one also will make 2 electrons. So I will do one thing actually here. Here I will do one thing. 1, 2, 3, 4. Right? Next oxygen. Here also what happened? Oxygen. Here also what happened? Oxygen. Now here 1, 2, 3, 4, 5, 6. Next year 1, what happened? 2, 3, 4, 5, 6. Next year 1, 2, 3, 4, 5, 6. Now you got a double bond here. Yes, here you are having a double bond. Right? Next, in this case, what happened? These 2 electrons will take what happened like this. I am removing these 2 electrons here. Here we can put one extra electron here. Here also I can put one extra electron. Now here the 2 electrons extra, no, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, no, sorry, extra minute. Here 1, 2, 3, CO3 minus 2, I have to put 1, 1, 2, 3, 4, 5, 6, extra electron. Yes, 6. Next. Next, what happened? 1. Now here what happened? 2, 4, 5, 6. The extra electron I'm putting like this. Now if you see this structure, what happened? This is an extra electron. This one is extra electron, right? Now carbon has 4. Each oxygen has 6 electrons. Now if you observe what happened, this is a structure of CO3 minus 2. Now if you observe here what happened, how many electrons you're having on oxygen? 1, 2, 3, 4, 5, 6, 7, 8. Right. This oxygen, if you observe 1, 2, 3, 4, 5, 6, 7, 8. This one, if you observe what happened, 1, 2, 3, 4, 5, 6, 7, 8 electrons. And in this case, what happened? 1, 2, 3, 4, 5, 6, 7, 8 electrons. Now all are having 8 electrons. Especially the central atom you have to see. The central atom is having what? 8 electrons. So this is the Lewis structure for what actually? CO3 minus 2. So you have to make all combinations so that what happened, where we are getting 8 electrons, that we have to select. If you select like this, what happened? We are not getting 8 electrons over the carbon. We are getting how many? 10 electrons. So you can select this structure as a Lewis. So the trial and error method, if you follow what happened, you will get the answer. Right? CO3 minus 2. In this way, this will be the CO3 minus 2. Right? Next, we will take one more structure also there. Which one will take? SiCl4 I will take. SiCl4 I am taking it. SiCl4. Now how to make SiCl4? SiCl4. Now here what happens? Silicon is a central atom surrounded by 4 chlorine atoms like this. 4 chlorine atoms. 4 chlorine atoms. Now the chlorine configuration, if you observe, 3s2, 3p5. This is for chlorine. And for silicon, for the silicon, if you observe,
3s2,
3p2. So here you have to make how many? 4 electrons. You have to make how many? 7 electrons. Now in that only one unpaired electron is there. So I am writing one unpaired electron here. This is the one unpaired electron now. 7 is completed. Remaining also same like this. Here also what happens? Same like this. Only one electron will be there. So now chlorine has 7 electrons, correct? Silicon should have how many? 4 electrons. So what happens actually here? 3s2, 3p2, shall I write like this? 3s2, 3p2, paired electron and 2 unpaired electron. Now if I shift this electron here, so you will get how many unpaired electron beta? How many unpaired you will get? If I shift this
4.
that means 4 unpaired electrons I am writing like this. 1, 2, 3, 4. Now between these two we get a covalent bond. We get a covalent bond, a covalent bond, a covalent bond like this. Now let me check here how many electrons is having. So if I select one chlorine, remaining also will have same electron. So I am selecting this one. So remaining chlorine also will get 8 electrons. Here we get 2, 4, 6, 8 electrons. Correct?
Sir, it satisfies.
Satisfied. Okay, no problem. Let me see this one. Next, what happened? Silicon. Silicon is also having the 8 electrons. 2, 4, 6, 8 electrons. Now SiCl4. Why I am writing like this? Because whenever SiCl4 is having, isn't it, octet configuration, isn't it? Then this molecule is stable. I can say CO3 minus 2 is stable. How in the previous structure, if you write like this only, it will be stable. Okay, by taking what here? 2 bonds, here what? Single bond, here single bond, then only it will be stable actually. So SiCl4 and CO3 minus 2 are stable because of what actually? Octet configuration, isn't it? Now, let me see now some exceptions here. Some are the exceptions. What are the exceptions we are having in this one? In some cases, what happen, you may have more number of electrons in the chemical bonding site. Let me see that one also. Now you can complete this NO2 minus beta because it is there. Okay, in the textbook it is there. You try NO2 minus, you try this one, right? Right. Next we'll see some exceptions are there here in the octet rule. According to the octet rule, what actually? Whichever is having 8 electrons, they are highly stable. Which are not having, they are unstable actually. No. Limitations of octet rule, let me see. Limitations of formal charge we see after this octet rule. The formal charge we discuss, everything we'll discuss later, formal charge. We'll see first of all, we'll complete this octet rule so that we'll get next one. Octet rule, limitations. First thing limitation is what? Incomplete octet configuration. What I told you actually, any molecule which is having 8 electrons in the outermost shell, they are stable. If they don't have 8 electrons, they're unstable. This is the octet rule actually. But there are some molecules are there, even though they are not having octet configuration, they are also stable. What are they? Lithium chloride, beryllium hydride, boron chloride. These are the some of the limitations for what octet. These are stable actually. Even though they are having what actually lesser than 8. You observe this one, lithium chloride, how many electrons you are having? In this only 2 electrons you have. In this how many you are having? 4. In this how many you are having? 6. But they are stable actually. See, lithium outermost configuration kitna hai beta? Lithium 2s1. Only you take what? 1 chlorine. Per chlorine how many electrons beta? 7 electrons. Correct or not? 1, 2, 3, 4, 5, 6. Now even in this lithium is having how many? Only 2 electrons. Right? Beryllium, if you observe what happened. Beryllium you observe. Beryllium configuration is what? Outermost configuration 2s2. Now write down the 2 electrons here. Hydrogen configuration is 1s1. Put 1 electron here. Put 1 electron here. Now on beryllium, overall how many electrons you are getting here? 4 electrons. Similarly, boron also same like this. So what is the first thing? Incomplete octet configuration, which are having lesser than octet configuration. The molecules which are having central atom, because we have to see first of all central atom. So central atom which has lesser than 8 electrons, they are also what? Stable. This is one of the exception cases. Right. Next we see what? Odd electron molecules. In some cases what happen? We have odd number of. Generally we should have 8 electrons. Correct? No. In some case, you may have odd number, like 6, 7 electrons you may have like that. Isn't it? Let me see this one, NO molecule, NO. So NO, I'm writing here, nitrogen and oxygen. Already you know oxygen will have how many? 6 electrons. I'm not writing the electronic configuration, directly I'm writing 6 electrons. Nitrogen valence electrons, how many beta? Nitrogen valence electrons. How many beta? 2s2, 5 electrons. 2s2, 2p3, 5 electrons. Now what is happening? So here they can form a bond here. Here they can form a bond actually. Now if you observe here what happened. Nitrogen carries how many electrons here? Here 2, 4, 6, 7 electrons. Leave it oxygen. Oxygen is having 8 electrons, isn't it? Leave it oxygen. But nitrogen, if you observe, having how many? 7 electrons. Lesser than octet, and that too what happened? Odd number. Here you are not having odd number, even number you are getting. Even number. But here you are getting odd number and also lesser than what actually? Octet configuration. Similarly, N2O also, same. Even N2O also same like this structure. If I write what happened, I want to write N2O, same like this. Oxygen, oxygen. Now oxygen will have how many? 1, 2, 3, 4, 5, 6. Similarly, here also what happened? Same like this. 1, 2, 3, 4, 5, 6. Nitrogen will have 5 electrons. 1, 2, 3, 4, 5 electrons. If I write like this, what happened? Now, how many electrons you're having on nitrogen here? If you observe what happened here, 1, 2, 3, 4, 5, 6, 7, isn't it? But if I write something like this, to make this one, what I am doing here, to make this stable, we'll do one thing. I am writing these 2 electrons here. Whatever the electrons of oxygen, I am writing here. This one is 4, no? 5th electron I am writing here, 6th electron. Okay. Now, oxygen 6 electrons are completed. Nitrogen has how many electrons now here? 5 electrons. So, I am writing this 5 electron, 2 more electrons, 3 more electrons like this here. In this way. Okay, now how many electrons you are having here? 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons. Again, you are getting what? Odd electron configuration. Okay, in this way. Otherwise, you can put like this also. So, you can put like this also. Now, I am not touching the oxygens of electrons here. There are what? Free electron, and just leave it this one. Now, the 2 electrons I am placing here like this. In this. Now, for this, if you observe, these oxygen electrons are not involving in the bonding. See, all these electrons are free here. Now, we are getting a bond here. We are getting a bond here. We are getting a bond. So, this we can show like this. N double bond O, N O like this. Now, in this case, nitrogen will have an unpaired electron, this one. So, total how many are getting here? 2, 4, right? 5, 6, 7 electrons we are getting. So, you should get 7 electrons. For that reason, we have taken like this. So, nitrogen is having how many? 1, 2, 3, 4, 5, 6, 7 electrons. Yes. Odd number of electrons is having 7 electrons. This is the structure of what? N2O structure. In this way, we can write. And finally, we'll take expanded octet configuration. Expanded octet configuration. Now, in expanded configuration, we are having more than 8 electrons. I am taking what? PF5. PF5 I am taking. So, phosphorus. Here what happened? Fluorine. Right. Phosphorus, fluorine, 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 fluorine. Now, phosphorus is having 3s2, 3p3. So, total what? 5 electrons. Fluorine is having what? 2s2, 2p5. Total what? 7 electrons. Now, I have to put here 5 electrons here. For phosphorus, I have to put 5 electrons like this. 1, 2, 3, 4, 5 electrons. For fluorine, how many? 7 electrons I have to put. I am putting here first electron here, second, third, like this. All the 7 electrons I am putting here. Here also what happened finally. Each fluorine is having 7 and phosphorus is having 5 electrons. Now, if you see this phosphorus central atom, how many electrons you are having here?
So 10 electrons.
You are getting 10 electrons. You are getting 10 electrons. So, actually, no need to find out. See, PF5, how many bonds are there here? 5 bonds. So, 5 into 2, 10 electrons. SF6, how many bonds are there? 6 bonds. 6 into 2, 12 electrons. In this case, how many bonds you are having around the sulfur? 1, 2, 3, 4, 5, 6. Again, 6 into 2, 12 electrons. In this way also you can find, but in examination, nobody asks you write this structure. What they say actually, following which molecule is having expanded octet configuration. In that case, they may give PF5, SF6, S2, S4, something, all of the above. So, all of the above will be the answer. In that way, you may get the questions. And following which is the odd electron species they ask, isn't it? NO, otherwise BF3, lithium fluoride, like that. NO will be the answer. And which of the following is the incomplete octet configuration, short of octet configuration? You have to identify that. So in this way, you will get the questions, actually, right? And this is only today's class. So you have to complete these Lewis symbols, okay? So in your notebook, what you have to write actually? You have to write, start from where? Octet rule. Rule, you have to write octet rule. Okay, what is that? According to this, okay? According to this, atoms can be combined like यहाँ पर आपको लिखना है, right? And after that, what happened? Write Lewis symbols for one or two molecules. Just take one or two molecules from this one, write the Lewis symbols. Yesterday we discussed this one, all these things. And this is a dot structure CO molecule you write in the notebook. And also what happened? I given today CO3 minus 2 also and NO2 minus 2 also. Formal charge we'll discuss tomorrow. And after that, in notebook, put a heading, limitations of the octet rule. First limitation, second limitation, and what happened? Third limitation. These are the today's we have completed and write down in the notebook actually. Tomorrow we'll start formal charge and remaining topics here. Right? Now, if you have any doubts, you can stay.
So we have to write other drawbacks of octet theory also.
Other drawbacks can be only 3 hai na. We are having only 3.
Sir, पीछे दिए हुए.